All right, so Andrew wanted to know about vertexy things. So for parabolas slash quadratics, what I expect you to know is the three forms, how to solve, and where the vertex is. So the three forms are f of x is ax squared plus bx plus c. Standard form. And I don't care if you know the names at all.
Okay.
Okay?
You won't tell us, like, put it in standard form or put it in...
Put it in the other forms.
Okay.
Okay? So, yeah, your book calls this standard form. You can either know that word or not. I don't care. There's vertex form, which is what?
A parentheses x minus h, other parentheses square plus k.
Okay, and what's special about this one?
It gives you the vertex.
Good. This is the vertex is at what? H comma k. And why is the vertex at h comma k? This is a shifting rules question, right?
Yeah.
So why is the vertex at h comma k?
Shifted left or right, h
Good, because this is a right shift by h, and that's a upshift by k. So of course, the vertex was at 0, 0, and now it's at h comma k. You guys all with me at that? Is that? Okay. And what's your other form? Yeah, the x-intercept form, which is factored into a times x minus r times x minus x, or something. There's something at the end.
What are the r and s?
Yeah, they don't have to be minuses, they can be pluses. And I'm actually not totally satisfied with this thing anyway. There are a bunch of different ways you can factor, right?
Yes.
You guys see that? Like, personally, I would say that, for example, right, if you had g of x is 3x minus the quantity 3x minus 2 times the quantity 4x plus 8, right? I personally would call this factored. You guys see that? But there's not, but it's not the same as this one. You guys see that? Yeah, so to get to a times x and x, right? I need to factor a 12 out of that thing, which is going to make this look really icky. You guys cool with that? So I'm willing to call this factored form, even though it's not quite the same as the one that your book calls factored form. You guys see what I'm selling there? Like, basically here I've sold having the A nice and out front for knowing where the, like, for having something that's easy to FOIL back out. You guys cool with that? Is it the same? Nah. Could you get it to be the same? Yeah. Cool. Questions, things? What's the other thing here? So I found the vertexes at h comma k. I believe that you guys could FOIL one of these back out, right? Can you factor? Do you remember how to do that?
Yeah, a little rainbow.
Yeah, no.
Oh, factor.
The unrainbow thing.
Yeah.
Right, so to factor, you might look for the AC factor method or something. So that's how I would get from here to there. Oops. So from the factored form up to this guy, what are you going to do? FOIL. From the standard form to the vertex form, what do you need to do? Yeah, complete the square.
And that's where you like add the blanks between certain things?
Yep, put the blanks in, divide by 2, square things, that whole jim jam. Cool? There's a divide by 2 in the complete the square procedure.
Oh, yeah, got it.
Yes, b over 2 needs to be in there someplace. First you want to divide by a first,
Oh,
right? Let's see, what else do I expect you to know? I expect you to be able to read the vertex off of this thing, or at least half the vertex.
Will you have a sample of the quadratic formula?
So where's the vertex here?
Negative
Something C.
Good, it's at x is negative b over 2a. Where's the y? Good, that's f of that thing, right?
Yeah.
You guys remember that? Y is at f of that thing. Because it's a point on the what? Because you plug in the x to get the y. Because it's a point on the
Vertex.
graph. Right? Remember a graph is the sets of input-output pairs?
Yeah.
So here's your input. To get the other coordinate, you need the output that goes with it. Yeah, so what's the other thing I expect you to know here? Yeah, how to get the x-intercepts, which you get from,
Zeros, maybe not 0.
yeah, from setting it equal to 0 and solving, right?
Yeah.
So what tool do you have for that other than factoring? Yeah, you also should have quadratic formula. Cool? You guys remember that thing?
Just for standard.
Yeah, so the quadratic formula
Squared minus.
says specifically if ax squared plus bx plus c equals 0, then x is negative b plus or minus the square root of b squared minus 4ac all over 2a.
You said you're wrong.
I know,
Please don't say it.
I'm not going to.
What? You told me you should.
I don't have very much dignity, but I have more than that. So the if statement here is important, right? Like specifically, you can't apply the quadratic formula if there's stuff on this side. You guys see that? So like, for example, or maybe for not example, right? If you had x squared plus 3x plus 2 equals 4x plus 7, right? This does not immediately lend itself to the quadratic formula, right? What do you have to do first to get it to fit? Yeah, move everything to one side, combine like terms, and then run the quadratic formula. Guys, cool?
Yeah.
Make sure too that your a goes with the x squareds, your b goes with the x's, and your c goes with the
Constants.
constants. Cool? Questions, things? Deal?
It's just what ends up a lot of that.
Yeah, this is algebra 2. Oh, where'd my, oh, you might notice too, the vertex is right there,
Yeah.
right? Why is the vertex right there? Because this thing's telling you where the x-intercepts are, right?
Yeah.
And they're symmetrical around the vertex. Cool?
So is
Questions too?
So
Yeah, isn't
what-
that cool?
what exactly is the b squared minus 4ac? Then if that's the vertex, what would that represent?
Good.
No
Cool.
difference.
That's actually an awesome question. I'm surprised.
Gee, thanks.
Kidding, buddy. So here's your x equals negative b over 2a, right? That's the x coordinate for the vertex. Now, the good question is this b squared minus 4ac, what does that represent? Well, that doesn't represent quite a thing on the picture, but this distance here is the square root of b squared minus 4ac over 2a. Okay. You guys see that?
On the vertex to the x-intercept?
Yeah, that's going to be the distance from the vertex to the x-intercepts, right? And you're going forward that distance on the one side and minus that distance on the other, which is why there's that plus or minus thing. You guys see that? What does it mean when that thing under there is negative?
The whole parabola is on the negative side.
Ah,
It means there's no intercept.
yeah.
Or it's broken.
It means there's no intercepts. So that can happen like this, right?
Yeah.
And then is the vertex formula wrong here?
No.
No, it's just weird because the distance, right? from the vertex x-intercept, or the distance from this guy to the x-intercepts is in the complex direction, which is not on this picture. Right, maybe I should do this to get that. You guys see that?
Yeah.
So even if that distance isn't on the picture, it still makes sense. That vertex is still in the right spot. Cool? Questions?
So how
Dale?
does that represent the distance then if both of them are negative? But it is since it's still.
Oh, if this thing is negative
Oh.
under here, so the square root doesn't make any sense, right?
Okay, yeah.
So that thing doesn't make any sense as a distance,
Okay, yeah. Okay.
but the vertex is still at negative b over 2a. It's just that that distance is now in the complex plane instead of the real number line, and it gets really screwed.
Understandable.
Cool?
Should we be expected to know how to like derive the x-intercepts from the vertex form?
Oh, yeah, sure. So if I asked where are the x-intercepts from this vertex form, right? What do you do?
Minus k divided by a. It's all-
Good. Set it equal to 0, right? So you'd set this equal to 0. Okay, so let's take our a times x minus h squared, it's supposed to be an h, plus k equals 0. Right? So we're going to say, all right, we'll subtract k. We got a times x minus h squared equals k. What is zero?
Negative.
Negative k. And then what?
Pi by a.
Sure, multiply by 1 over a. So you get x minus h squared is
Negative k over a.
negative k over a. And then
Square root plus or minus.
plus or minus square root both sides. So you'll get x minus h is plus or minus the square root of minus k over a. So I better notice, right, 1 of k, oh my god. 1 of k or a, right, better be negative, otherwise this thing doesn't make any sense. Right? And then what? Add h, right? So you get x is h plus or minus the square root of minus k over a, which you can chase back into the quadratic formula if you really give a shit.
So it's just a matter of
Cool.
setting equal to 0.
Yeah, that's really all the x-intercepts are anyway, right? They're when is the output 0? So set it equal to 0 and try to solve. That's how you would do the x-intercepts for any old thing. In here, you could try a different tactic that would also work. You could multiply this crap out, get it into the standard form, shove it in the quadratic formula. You'll get the same place. This is, of course, faster and easier, but whatever. Cool? Questions on parabolas otherwise? No? Good. I think you guys are probably good on these.